Hello, and welcome back to Learning with Lee. And welcome to the first in a several-part series on pointers, dynamic memory allocation. We're going to be covering several of the different standard libraries that exist out there for C and C++, as well as also then we're going to get into a bit of algorithms. I know that this might be a lot to take in, which is why I'm going to be splitting it up over several episodes, as well as also I might be a bit redundant in some things that I say over the course here in terms of things I've already said in earlier episodes, as well as repeating myself a few times in here. However, I consider that redundancy to be a good thing to make certain that all of the people who watch this video have the ability to understand and really grasp the different ideas, because I'm going to be throwing a lot at you guys, and I don't want you to get confused or lost. So the first thing we're actually going to take a look at, before we get into any of the stuff directly related to the coding of this algorithm, is the algorithm itself. And the algorithm we're going to be doing for this is a sorting algorithm that will take some array of integers, such as this one here, and similar to this one down here, and then convert it so as that its smallest element is first and its largest element is last. And that should be viable for really any set of integers that we give it. So there are many ways in which we can do this, frankly. There are quite a few different sorting algorithms with different complexities and different advantages and disadvantages to them. And the one that we're going to be using today is what's known as merge sort. Merge sort happens to be a fairly popular one in that it's reasonably elegant, reasonably simple to implement, and it happens to also give good performance in addition to those other advantages. It's probably one of the most common ones alongside quicksort that you will see implemented in actual use. So the way in which it is let's say that we have this array of integers. Each of these I'm just going with a single digit for now just to make it a bit clearer and cleaner. So what you do is you begin first by breaking down this array of integers. And really what it's going to end up being is that it's eventually going to end up being so that each one of these integers is just by themselves. But there's a reason why we actually do it like this, in which we're going to take this, and similar to how we did the binary search earlier, we're going to split this in half. And we're going to subdivide the problem. Because basically what we're doing when we do this is we're recognizing the fact that if I were to treat these as two separate arrays here, I could sort this array, and then all I have to do in order to figure out the sorting of this parent array is take something such as this element here, move it down here, move this one over, this one then behind it, and then sort of do this process of, since these are already sorted, you just insert the smallest one at the beginning and you can move directly across the array. You don't ever have to go, I need to take this guy and insert it at the very beginning and then shift a whole bunch of other numbers back. And when we start getting into the various sorting algorithms that are out there, you'll really understand why merge sort and quicksort are used. So what we do is we split in half. Then, once again, as you can imagine, we keep splitting it in half. And we keep doing this until we end up reaching a point where each of these is effectively their own individual array. I know there's a couple elements over here that I didn't bother to write out yet, but this still is a good enough example. So what we have now is we have the ability in order to then go, each one of these is already sorted, because if 2's by itself, it's already sorted. There's no other way in which you can permute it in order to have it be better oriented from smallest to largest, since there's only one element. So what we then do is we take the two of these, and we merge the two of them together. And the way in which we do that is we go, okay, we now have an array of 2 down here. And what we can then do is we can go, this one is smaller than this one, so we insert this here. There's no other things in this first array, so we just insert this onto the end. Then we repeat that here, and as you can imagine, 3 goes first, 5 goes second. And over here we encounter our first situation where this is actually different, in which the 4 goes in this one, and then since there happens to be none left in this array, we move the 7 over into this position. So, once we finish up with this row, we move on to the next row, and we basically then merge together the two of these. And for the process involved in doing that, what we do is we just end up taking this guy here and we go, okay, we have 2 and 8 and 3 and 5. Well, 2 happens to be smaller than 3, and we only need to make that check because we already know that this is sorted, so we don't need to compare 2 to 5, we don't need to compare 8 to 3. We just need to compare these first elements. Whoops, gave a bit of a smudge there, but we can go, okay, 2 is less than 3, move it down. Then we effectively go 1 over in here since we've already put 2 into this next array, and we can compare 8 to 3. 3 is less, we move it over, and for this one here, we now are over on this one. We then compare 5 and 8, move 5 into its spot, and finally insert 8 down here. And we do this all the way down until we end up having this built up again, except in the correct order. To continue with that, before we get into any of the coding, let's consider how we would actually implement this algorithm as code itself. So, just to briefly cover the steps and sort of break them out into the different parts we have to do. We have to have a few steps to basically split it. So, we have that. Then down here, we have to have at least one step to merge. And I'm saying at least one step, and the idea here is that, and what you'll see is that this is a very elegant recursive algorithm, which is why it's very popular, in addition to its other advantages. So, really what we have to do is we end up with some function that takes in an array. Then, we have to end up splitting that array into 2 other arrays. Then what we want to actually do, and this might seem a bit odd, but we then want to recur on both of those arrays so that we can continue splitting them until we reach a single element. I've left out the step in terms of us actually having to check for whether or not there's only a single element left, and if we care about that, that check would go right up here. However, since that's not too big of an issue for just writing out the general algorithm here, we have to split our array into 2 subarrays. We want to recur so that we can keep splitting the arrays. And then once we're finally done splitting the arrays and we're down to basically 2 one-size arrays, we want to merge those together, and that'll basically happen along this spot here where we have a whole bunch of these one-size arrays because they're already then fully done with the split-ups. We're down to these. This step here will occur when we do this first merge. Then when we end up returning from this function call, basically this would be fb, we would end up going down fc, which would eventually lead us to having this. And then when fc is done, we would have to merge b and c right here in this step. And you can see sort of how then I would eventually, when that one's done, have another one over here in which I would then have to merge it with another array over here, and do that again, and you can see how that ends up sort of expanding out, and we wind up with it being a fairly short, concise, and compact algorithm that's relatively easy to do, easy to code, and reasonably easy to understand. So to give you guys a brief taste of what the code actually looks like for this, which I'm not going to go too heavily into until the next episode, because there's quite a few different things in here that I need to properly cover. We have, first, our merge sort here, and this is just going to be used to call our recursive algorithm. And the reason why you might notice, such as in here, I have size -1, and that's because I'm converting from a size to indices. And in case I have 10 elements in there, my final index would be r sub 9, because, as you might remember, we start out at 0 for our array sizes. So then in here, here's our first check to make certain that we only have more than one element, and in case we only have a single element, we return. And one of the important things about this is that this version of it is modifying this original array here. We aren't creating a new array and passing it back. We are modifying the original values. Then, what we do is, as I said, we have to split the array into two arrays. In this case here, I'm just doing this using indices. So we know the start index for our array, we know the end index for our array, which if we head over here and we take a look, say, down at this guy here, this one here might only have 8, 9, and 5 in it, but I know what my start index is, so that'd be my start, and this would be my end index. And I would have to figure out how to split that up, and that happens to be done by this other function that I've written just to keep it a bit cleaner for us. This purely was some debug code I included in here to make it a bit easier to understand what's going on, and I'll show you some debug output as we go. And then, as you can see, we have these two recursive algorithms that, well, these two recursive calls that end up performing the algorithm of splitting it up. So, well, this one will do is it'll go in and it'll take the first half of whatever our indices covered in here, and that'll split that into two parts, and continue recurring until it's split them all down to single elements. Then this one here, it'll do the same thing for the second half of that array. Finally, once we end up reaching here, we do, as I said over here, the merge step of combining the sorted arrays together. And we're going to get into all of this because there's a fair amount of complexity as we start heading down into, say, here in particular, for why this is how it is. And some of the aspects are things that we have not yet examined in the course of this series. So, thank you very much for watching. I look forward to continuing this discussion next time. I hope you have a wonderful day.